Hi folks, this is Beginning Algebra, Take Home 7. We're given a rather complicated looking absolute value inequality. Normally when we have compound inequalities like this, we would just isolate the x by adding 3 everywhere. The problem is we've got these absolute values in the way. And so what we're going to do is break this down into a compound inequality, and then we'll have two absolute value inequalities, which we can then solve using the stuff we learned in Section 8.2. So to break this back into a compound inequality, we have 1 is less than the absolute value of x minus 3 and the absolute value of x minus 3 is less than or equal to 5. So to solve this first inequality, it might be helpful to rewrite it as the absolute value of x minus 3 is greater than 1. So we have the absolute value of something bigger than 1. So either whatever's in there is greater than 1, or whatever's in there is less than negative 1. I'll solve both of these inequalities by adding 3 to both sides. So I get x is greater than 4, or x is less than 2. And if I visualize that on the number line, here's 2 and here's 4. X greater than 4, open circle, everything to the right. Less than 2, open circle, everything to the left. And since we have an or, we lump these two together. So both of these are parts of the solution. Now I go to the other side. X minus 3 is less than or equal to 5 in absolute value, which means that x minus 3 is trapped between 5 and negative 5. Since there's no absolute values here, we can solve this compound inequality by adding 3 across the board. And so I get negative 2 is less than or equal to x is less than or equal to 8. I can graph this on my number line. Since it's less than or equal to, we have filled in dots, and everything between negative 2 and 8. So these are the two parts of the solution. The and means I need to intersect, which means I need to find the overlap between these two parts. So let's draw them both on the number line and look for the overlap. So we have negative 2, 2, 4, and 8 are the key players here. We have everything from negative 2 to 2 up to and including the 8. We have x's that are less than 2 and x's that are greater than 4. We need to find the overlap of these two sets. So as I start going from left to right, where do I overlap? Well, I start overlapping at negative 2. Negative 2 is in both, up to but not including 2 itself. And as I keep moving to the right, I start to overlap right above 4 and less than or equal to 8. So this part I can describe with a bracket, negative 2, 2, parenthesis, union, parenthesis 4, comma 8, bracket. And once again, the way we could check that this really is the answer is we can break these four numbers have broken the real number line up into 5 pieces. We can take a test value at each of the 5 pieces and check to make sure the equality actually works in the intervals which we've listed as our solution. And so that'll do it for Take Home 7.